Okay, section 1.5, problem 13. Maybe the weirdest thing about this group of problems was just trying to figure out the directions and what it was they wanted you to do, because they probably asked you to do too many things at once. So I'm reading it here, guys. It says to find a domain on which f is 1 to 1. So right there, it kind of tells you something, that f of x, the way that it's given right here, is possibly not 1 to 1, since I'm supposed to find a domain on which it is. Now, this is a function here, everybody, that is not one that you're expected to know the graph of by hand, so don't feel bad at all if you had to go to your calculator in order to type this one in. This is kind of a cool graph here that does some interesting things, and like I said, not one that I would expect you guys to come up with on your own. But what you might do, just out of a little intellectual curiosity, is maybe start plugging in some numbers. If I put in a 0 for x, I can see pretty quickly that I'm going to get 1 over 1 here, so this is going to pass through the point 0, 1. When I go to put in a 1 for x, I get a 1 plus 1 is 2. This is 1 over the square root of 2. And 1 over the square root of 2, which is my y value when x is 1, is a little bit less than 1. It's actually about 0.707. And now, if you just start to think about what's going to happen, as x gets bigger and bigger, as I let x become 2 and 3 and 4 and eventually 10 and 100, my denominator is going to keep getting bigger and bigger. My numerator is going to stay put at 1. That means that for this particular function here, as x goes out towards infinity, the value of this function is going to decrease and approach 0. And I know a little bit about this curve here, guys. It does so with kind of a funny little curvature, maybe looking something like that. That's what it looks like on the right. Now, what I'm about to ask you next is a question I hope you ask yourself, and let's see if you guys can come up with the answer. What's going to happen now as I consider negative values for x? Well, if I put in -1, I square the -1 to get +1, plus 1 is 2 again, and once again I get 1 over the square root of 2, which is about 0.707. Now, what I hope you saw is whether you put in a 1 or a -1 right here didn't matter. The first thing you did was squared it, and you got the same result. Everything on the left is going to perfectly mirror everything that happens on the right. So the graph here is going to look something like this, but what I'm hoping you guys recognize is that this is an even function. It's exactly the same on the left as it is on the right. It doesn't matter whether you put in 5 or -5, you're always going to get the same result. Now again, back to my directions here. It said, to find a domain on which this function is 1 to 1. And yep, kind of like I thought, this function right now is not 1 to 1 because I can see pretty clearly it fails the horizontal line test. The real reason here, guys, is that for this one y value, there are actually 2 different x values that give you the same result. So I can tell right now, let me make some notes right here, that f is not 1 to 1. I'll abbreviate that. And what that tells you, maybe you remember this symbol for therefore, that tells you that the inverse of f is not a function. If a function, such as f, is not 1 to 1, its inverse is not a function. F fails the horizontal line test. That means that its inverse would fail the vertical line test. Now, let's see what I can do for you here, guys. This is something I'm hoping you guys could think of a little bit on your own. The inverse of this graph is not that difficult to come up with. The first ordered pair that we came up with for f was the ordered pair 0, 1. In fact, let me go back to blue right here. So here on f, I guess I'll just write this out, f of 0 was equal to 1. That tells us now, guys, that when we go to take the inverse, okay, f inverse, when we plug in a 1, we end up with 0, and we get the ordered pair 1, 0, like that. That's a start. Okay, the next ordered pair we came up with in blue, I guess let's be consistent here, we plugged in a 1 and got f of 1 was 1 over the square root of 2. All right, that's the ordered pair 1 and then 1 over root 2. Now if I invert that in green, I get the opposite of that. I shouldn't say the opposite, excuse me, the inverse. F inverse of 1 over root 2, that's my x value, gives me a y value of 1. So that point is going to end up maybe right about here, and I'm going to get a green graph here that stays in the first quadrant but approaches the y-axis as y goes up towards infinity. A couple things to think about right there. I want you guys to notice that on the original blue curve, there's a whole bunch of points. Let me just pick one of them out here. That's a first quadrant point. It's got a positive x value and a positive y value. When you go to take the inverse of a first quadrant point, you switch your x and your y. Well, when you switch a positive and a positive, you end up with, that's right, still a positive and a positive. So the inverse maps up here, and it looks something like that. Now the second half of this graph is going to reflect down below the x-axis and look at something like this. Now again, to kind of prove the point right here, let's look at a point over here maybe on the original graph, which had a negative x-coordinate and a positive y coordinate. And when you go to invert that ordered pair, you switch your x and your y there, and we end up now with an ordered pair that is going to have a positive x coordinate and a negative y coordinate. That's how we end up down here in the fourth quadrant. So what we have in green right there is the graph of the inverse of f. But kind of like we thought, the inverse is not a function. So as fun as all this was, guys, I'm going to erase a lot of this junk right here. And let me start actually answering the question now, which I know is what you guys want to see. First of all, let me read this again. It says find a domain on which f is 1 to 1. So let's look back at the blue curve. We can see that one is not 1 to 1 because it fails the horizontal line test. So all I'm going to do, there's multiple ways to answer this, but really the simplest way would have been to quit while I was ahead. If I just erase this entire left half of the blue curve, everything that was in the second quadrant, I now have a domain here for the original function f where it is 1 to 1. So let me go ahead and start answering here. F is 1 to 1 on this domain here that starts at 0 and it never ends, so we'll put an infinity there. 0 is included in this domain, so I'll put a bracket on the left, but of course you never equal infinity, so that's always a parenthesis. So that's my answer to the first question. Find a domain on which f is 1 to 1, did it. And a formula for the inverse of f restricted to this domain. Okay, so I'm going to go to green now. And here we go. We're going to take the original function, which was right up here, and we're going to find the inverse of it. Step 1, switch your x and your y. This was a y, so we now get x is equal to 1 over the square root of, and my x becomes a y squared plus 1, and we want to solve that for y. I'm going to do this little trick here, guys, that hopefully you've learned. You can switch, basically this is the numerator of one side of the equation, the left, with the denominator of the other side. So the square root of y squared plus 1 is equal to 1 over x. All right, we are now going to try to solve for y by squaring both sides of the equation, and that is going to get us y squared plus 1 is equal to, and that's a 1 over x squared. The next thing we're going to do, I'm sure everybody sees, we're going to subtract a 1 here on the left, and you'd expect me to do minus 1 on the right, and I'm going to, just in a slightly different form. Instead of writing it as 1, I'm going to write it as x squared over x squared. Now hopefully you see that still has the same value of 1, but now that does something for me here. I end up with y squared equals, and now these two fractions have a common denominator. I can go ahead and put them together as 1 minus x squared all over x squared. And nobody at this level is going to tell me that they can cancel out those two x squareds, because you cannot cancel terms. You can only cancel factors. Okay, we're almost at the end of the line here with what we can do with this problem, but we're going to take the square root of the left, and remember guys, when you take the square root of an entire fraction, you're taking the square root of both the numerator and the denominator separately. So we're going to end up with y equals. Now in that numerator, you can't do anything to clean it up. It's just the square root of 1 minus x squared, but the denominator is the square root of x squared, which is just plain x. Now, one thing I should caution you, anytime, as we did right here, that you introduce a square root in solving an equation, there really should be a plus or minus in front of your answer. However, let's go back and let's think about what it was we were trying to accomplish within this problem. They said, come up with a domain on which f is 1 to 1, and we did that right there. The reason for that is we want the inverse only to be the inverse of this new 1 to 1 function. That means, you guys, take a look at my green graph up above. The same way that I erased the left side of the original function, I'm now going to erase the bottom half of the inverse, as if it were never there at all. And what that means there, guys, is that the y value of the inverse can only be 0 or anything positive, but we can't let y be negative. If we do, looking like this thing would not have been a function, and that's not what we're going for right here. So for that reason, I'm not going to worry about the plus or minus here, and that's my inverse. So I'll go ahead now and say my formula for f inverse would be this one right here, the square root of 1 minus x squared all over x. So let's read my directions again, and a formula for the inverse of f restricted to this domain. Okay, so the same domain we came up with above, that thing is only going to be valid for x values from, actually that's really from 0 to 1 is as high as that goes. Okay, we did that, found the formula for the inverse of f, got it, and sketched the graphs of f and f inverse. I suppose I could label those, that this would be the graph of f inverse, and back to blue now, this would be the graph of y equals f of x, and we'll put that right there. Okay, so long-winded, but those are the two answers that we needed, and then of course we needed the graph here as well, and that's number 13.